Video lecture series of analog and digital communication. This paper is there in the fifth semester of electronics and telecommunication engineering branch. So today we will discuss about the generation and detection of AM signal. The AM wave, how it is generated, that conceptual part we will cover today. So the outline of the today's presentation is the generation of amplitude modulated wave and the detection of amplitude modulated wave. So under generation, we'll go for low level generation and high level generation. And under detection, how to extract message signal out of a low level generated amplitude modulated wave, and how to extract a message signal out of a high level amplitude modulated wave. So as far as generation of amplitude modulated wave is concerned, so as it is written over here, the electronic circuit which is used to generate an amplitude modulated signal is called as an amplitude modulator. So the amplitude modulator, what it exactly does, it provides you amplitude modulated signal, and the modulation occurs due to an instantaneous value of the message signal. So here the modulation occurs at low level and high level, which implies the level at which the carrier signal is operating. So if the carrier signal is there kept at low power level, that will be called as a low level process. That means in low level AM generation, we will have a carrier signal which is at low power level. And in high level, we'll have a carrier signal which is at high power level. So as far as low level AM generation is concerned, here we will have the amplifier circuit at the extremely output stage. That means we do not have any modulator, means amplifier before modulator circuit. So the RF oscillator, generally the oscillator that provides a high frequency signal, that means radio frequency signal, which is the carrier signal. So when the carrier signal from the RF oscillator is generated, it directly fed to the modulator circuit. It is not amplified before the modulation process. So as you look over here, here the RF oscillator is there, which provides the RF signal, that means the carrier signal, to the AM modulator. AM modulator gets the message signal which is there according to its instantaneous value. The carrier signal's amplitude is get changed or modulated, and we got a modulated signal as the output of AM modulator, amplitude modulator. That output signal before transmitted to the channel is get amplified by a power amplifier. So at low level AM generation, we will only have a amplifier for the oscillator, means carrier signal, exactly at the extreme end. Okay, so that is written over here. The transmitter only have the amplifier circuit towards the final stage, towards the end, to avoid the distortion. Okay, that means when the signal is get transmitted or propagated through the channel, to avoid the distortion, means to avoid the attenuation of the carrier signal, it need to be converted to a high level signal. Okay, so this kind of low level generator circuits, they are basically used in non-commercial communication. So the advantage of low level AM generation is that it is very less complex in nature. The circuit is very simple in nature, that we will discuss afterwards. But in this case, the signal is at low level, so that's why it is very susceptible to the external noise or distortions after modulation. Means after modulation, when the signal is get transmitted to the channel, if the channel is in modern communication, we are getting the non-physical channel, that means wireless channel, when the signal is exposed to the whole means environment. So in that case, if the signal, modulated signal, is kept at a low level, it will become more susceptible to the noises or distortions in the environment. So that is the disadvantage of your low level AM generation. So let's move to high level AM generation. So in high level AM generation, we do have the model amplifier circuit before the modulator. So as you look over here, you are having the message signal which is provided by the mic, and the message signal is get amplified and it is provided to the modulator. and the other channel of the transmitter, that is the carrier part, means carrier channel, where the oscillator, RF oscillator, that provides the carrier signal, that is fed to the buffer amplifier. The buffer amplifier is there to avoid the overloading of the subsequent stages over the RF oscillator stage. Now, before modulator, the carrier signal is get amplified. For that, power amplifier is kept before modulator. So, the before modulation process, the carrier power is brought to a high level. So here the modulated signal that produced after the modulator, it becomes a high level modulated signal. So when that signal is get transmitted by the antenna to the channel, it will become more immune to the noise. So it cannot get easily affected by the noise. So as it is written over here, in high level AM generation, the modulation of AM signal is carried out towards the last stage of radio transmitter, and the amplification that has finished before the modulation. So this type of high level AM generators or AM transmitters are used in commercial AM broadcast. So advantage of high level AM generation is that it provides you high power and high efficient carrier signal for long range transmission, which is less susceptible to the noises after modulation during the propagation through the channel. And the disadvantage is that it requires higher modulating circuit, higher power modulating circuit. So the designing of the circuit becomes more costly, so which is written over here, and that is also more complex in nature. So as far as detection of AM signal is concerned, AM wave is concerned, so detection of the message signal by, as you know, that is it is extraction of message signal out of the modulated signal. So there are two types of detection or demodulation: extraction of message signal out of a low level modulated signal, or high level modulated signal. So if you are extracting message signal out of a low level amplitude modulated wave, that kind of extraction or that kind of demodulator circuit is called as square law detector. If you are extracting message signal from a high level amplitude modulator wave, that kind of detector circuit is called as linear diode detector. In both the circuit, the diode is there, which is a normal PN junction diode, but in your square law detector, the diode operated in its nonlinear region. If you go for to your VI characteristics of diode, the before your knee voltage, the current rises exponentially with respect to the input voltage. So that is the nonlinear region. So as soon as the knee voltage is achieved, then the current, output current, that rises linearly with the input voltage. So in that case, to operate the diode in the linear region, the input signal must have sufficient amount of power, high power level. So let us move to the square law detector, which is used for low level message extraction. Here, as you see, a diode is there, which is connected with an input voltage source. That input voltage source is connected with a DC source, which is in series with that, and there is a filter which is connected after the diode, and at the output of the filter you are getting the message signal. So here if you look over here, it seems to be a half wave rectifier circuit, but the thing is that here what happened, the diode is kept forward due to the presence of this DC source. Okay, this AC source that provides you the sinusoidal input. The sinusoidal input do have a positive half and a negative half. If your DC source, DC battery would not have been connected over here, then during the positive half of the input AC, the diode will move to the forward bias, and during the negative half, it will move to the reverse bias. So it will not provide any part of the reverse lower half of the negative cycle to the output. But due to the presence of this battery, it helps in making the diode forward bias during the negative half of the input voltage also. So in that way, what would happen? The lower part of the lower half of the carrier, if I may be permitted. So the lower half of the carrier is get compressed and the upper half is get expanded. So in that case, what would happen? If you take the amplitude, average value of the amplitude, unless and until the upper half is get extracted and the lower half is get compressed, if they both the half are in of same amplitude, then if you take the average value of the both the amplitude, then it will always become 0 volt. But if the positive half is get expanded and the lower negative half is get compressed, then the average value becomes sinusoidal in nature. So this output, that is not the average, that is the average value of the lower and upper halves, okay, which is sinusoidal in nature, and that is nothing but the message signal. So here something is written that it is used to detect the message signal from a low level amplitude modulator signal that I have told. The circuit is said to be a square law detector circuit because the output of the circuit is proportional to the square of the input. Here what would happen? When the input voltage is given, the output current flows through the load. Now the output current I, that depends upon the input. If we go for the mathematical analysis, then we can see that the current I, output current I, that would become proportional to the square of the input voltage V. So we will not go for that mathematical analysis. So here, as I have already told, the diode that operates in the nonlinear region of its VI characteristics. So as far as the linear diode detector is concerned, it operates at higher level. The diode is operate in its linear region, that means the region after the knee voltage of forward breakover voltage. So this type of demodulator circuit is used to extract the message signal out of the high power modulated AM modulator wave. Here the diode operates in its linear region of VI characteristics. This particular circuit is simple and cost effective, and it requires a strong carrier signal, as I have already told. So if you look over here what would happen? As no extra DC source is connected in series with the input source, source AC source. So what would happen? During the positive half, diode moves to forward bias and it provides you certain signal. But during negative half, what would happen? During negative half, the diode that will move to reverse bias and it will not provide you any output. So only the positive side that will reflect across the load. So if we get the positive side, that means positive amplitude. So their amplitude, that means the amplitude of each positive cycle. If the positive cycles are kept closer to each other, if the frequency of the AM modulated wave become kept at a high value, extremely high value, then the change in the amplitude of positive half, that seems to be sinusoidal, and this is the envelope. That's why it is called as envelope detector. This portion, that means this portion. This is the amplitude of first cycle. This is the amplitude of second cycle. This is the amplitude of third cycle, fourth cycle, fifth cycle. So if I will take the amplitude level, then I will have that envelope, and that envelope is nothing but the sinusoidal signal. So if the amplitude changes sinusoidally, so that provides us a message signal exactly at the output of the detector circuit. So with this, we have come to the end of this lecture. In next lecture, we will discuss about the generation of this AM signal in detail with detection means discussion of certain AM generators. Thank you.